Hello everyone, welcome to ISTQB training, CTFL session number 2. Let's start our session by first having a recap of what we did last week. We went through the structure of the foundation level exam. We also went through the definition of testing, what is testing, then what are the objectives of testing, and also the difference between testing and debugging. Okay, so today now we will be covering two topics under fundamentals of testing, which is why is testing necessary and also 7 testing principles. Okay, so in why is testing necessary, we will cover these learning objectives, which are examples of why testing is necessary, relationship between testing and quality assurance. We will also distinguish between the term error, defect, and failure, and also the difference between root cause of a defect and its effects. Okay, so first of all, let's begin with why testing is necessary. So this is because we all do make mistakes, and intensity of mistakes may vary. Like some can be minor mistakes, and on the other hand, some can be very dangerous. They can be even life-threatening. So testing is required to assess the quality of the system, identify defects, which can reduce the number of defects from the system, and eventually it can improve the overall quality of the system. And there can also be a requirement to perform software testing to comply with legal requirements or industry specific standards. For example, if we take an example of aviation industry or medical industry, they all have different standards, and testing is required to meet those standards. Let's move on to the next slide. We can over here take an example of an registration form, and we will go through all phases of SDLC, and we will see that at each phase how testing plays an important role. Okay, so now over here, if you see that this is a registration form, and it has some generic fields like about yourself, then about ID and password, and also in case you forget your ID or password, all these. So this is a registration form I have taken when we set up a new Yahoo email. So this is that application form. Okay, so on the right hand side I have stated 4 phases from which the testing of this form will go through. So it will be requirements, design, development, and release. So usually what we do is that we associate the term testing with only this phase, that when it's about to release and the product is developed, at that time we execute tests, and then if there are any defects, then of course those are fixed, and then we sign off on testing and release goes to live. But actually this is not a good practice. We should be including testing in all phases of SDLC. Let's see that how it can make a difference. So let's start with the requirement phase. In a requirement phase, testing can reduce the risk of developing a functionality which is incorrect or untestable. So we can take an example. So let's say if in this form we don't have any requirement for an email field, then what will happen? Then it will go like that to the design phase. It will be developed without an email, and when it will be tested, then we will get to know that there is no email over there. Of course, we do need an email as a unique a unique thing in the application form. We need something to communicate. This is like an important thing in the registration form, because this registration form is for creating an email address. So just imagine if you don't even have an email field, then what's the point of having this form at the first place? Let's take a second example of multiple browsers. So let's say that in the requirements it was not covered that this form should be used, will be used in multiple browsers, and let's say that only Chrome browser was taken into consideration while it was in the requirement phase, and then it was developed and tested also in Chrome. But when it goes to production, then the real users are using it in multiple browsers, and let's say the form is not appearing correctly in those browsers, or there is any other issue. So these are the things which, if testing is done properly in the requirement phase, then it can spot out these kind of defects, and it can prevent the defects to creep on to the later phases. Now let's move on to the design phase. So the testing in design can reduce the risk of design defects and identify the tests. Okay, so now over here, this is where we start identifying that what kind of tests we will carry out, and then based on that, then we write test cases. So let's say that over here, the name field, if the name field is not an alphanumeric, but if it is a drop down over here, then that wouldn't be a good practice. That wouldn't be appropriate, because later on in testing, when we will do testing, then we can figure out that the drop down can only accommodate few pre-populated names, and will not be able to add name by ourselves. So this would be a design issue. The same goes for the format of birthday. So let's say over here it says select month, then we can enter day and year. So if we don't have a specific format for birthday, then that would be a design issue as well. So testing at this phase can identify these kind of defects. Then let's go to the development phase. In development, it can reduce the risk of defects in code. So over here, let's take an example that if over here it says that the name is a mandatory field, but on the back end in the code, there is no check for the name field being mandatory. So what will happen that when we will run the test, that will fail. Same is with the not trimming the extra spaces on this field, on this alphanumeric field. So if we are not trimming extra spaces, then even if we enter space, it will take it as a character. So these kind of checks need to be there in the development phase, so that it can prevent the defects to creep on into the testing phase. And finally, in release steps, detect failures and get them fixed. It also increases chances that software is meeting the customer's requirement. So over here, we are actually executing the test which we identified and designed earlier. And while we execute the test, if we find out any kind of deviation from requirements, then this is where we report those defects and get them fixed. So that shows that how testing is necessary in different phases of SDLC. So this is just an example, but of course it applies to all kind of other products and softwares as well. Right, so let's go through now what is the relationship between testing and quality assurance. So now these are two terms. So the term quality assurance is often used to refer to testing. So though quality assurance and testing, they are related to each other, but still they are not the same. They are actually related, by a broader concept of quality management. So quality management, it ensures that an organization, a product, or a service has a consistent quality. So it includes both quality assurance and quality control. Right, so let's first go through what is quality assurance. Before that, let's go through this bullet point. So testing on its own does not improve the quality of the software, but until we test it, we cannot know what the quality of the software is. Okay, now this is very important because this usually comes in the exam, where there is usually one option given that testing improves the quality of the software, which would be absolutely incorrect. So please don't fall into that trap. Testing is basically a process where we assess the quality, we find defects, we get them fixed, and this entire process then reduce the number of failures and eventually improve the quality of software. But testing on its own can't improve the quality of the software. So keep an eye on these kind of questions. Right, okay, so the second one is quality assurance is an activity of defect prevention rather than defect detection. Okay, so quality assurance is associated with this activity where we can prevent the defects. And just like we say that prevention is better than cure, so quality assurance can defect the prevention, while we can associate the activities which are done in quality control with the defect detection ones. So by understanding the root causes of defects found, lessons can be learned to improve the process for future projects. By helping prevent the same mistakes being made applies to both development and testing. So once we do the root cause of defects which are found during testing, it can help us to improve the quality of the future products, because we will learn some lessons and we will try to avoid the mistakes which we made in a specific project. So testing should also be included as a quality assurance activity. Okay, so now if we talk about quality control, so quality control involves various activities that support the achievement of appropriate level of quality, and this also includes testing activities. And since quality assurance is concerned with the proper execution of the entire process, quality assurance also supports proper testing. So I hope that the concept of how testing and quality assurance terms are related to each other is now clear. Okay, let's have a look at the next slide, which is the difference between error, defect, and failure. Okay, now these are the three terms which are very important to differentiate that what do they mean, because many times many students, they just mix up these terms and use it in place of one another. So let's first have a look at what is an error. So an error is something which we can say it's a mistake which a person makes. So anything, any mistake made by a person for any reason is known as an error. Now, why that person will make a mistake, there will be different reasons for that. It can be pressure of work, it can be tight deadlines, and it can be that the code is very complex, it's quite tough, or it might be that there were some interactions with other systems due to which an error was made, or maybe the person who made the mistake is unfamiliar with that specific technology. So once an error is there, that error can lead up to a defect, which is also known as a fault or a bug in the software. So an error can cause a defect in the software, which then can be transformed into a failure when that software goes into operation. So let's go through it again. A person makes an error, that may create a defect in the software, which in software may cause a failure in operation. Okay, so now the failure in operation, they can also be due to some other reasons which are may not related to any defect in the software. They can be any environmental conditions, because sometimes you might have noticed that one functionality, it works on a specific environment, but as soon as we go to the production environment, it fails over there, so it causes a failure. So in this condition, it's an environmental factor. So once we go into details, of course, there can be many other reasons as well related to environment, configuration, etc., which can be identified. And the other one is that not all unexpected test results are failures. So if we are getting any unexpected result in production, it doesn't mean that it is a failure. Again, the root cause need to be identified, that what is the actual reason. So I hope that the concept of error, defect, and failure are clear, and you should be able to identify and differentiate between these three terms. It's a series of events which goes backwards. So that's what we meant, that if we have figured out this issue during testing, then we will go backwards and see that where actually was the issue, why there was an error, because clearly it's not behaving the way it was stated in the requirement. Okay, so in the development phase, if we go back to the development phase in the coding of this specific requirement, it was spotted out that it was written if purchase is equal to and greater than 50 pounds. So we got the issue over here. We noted that over here this if statement shouldn't have equal to, it should only have greater than 50. Fine. Okay, so that's good. We spotted out that why we got an issue over here in during testing, why we found out, because in the code it was written equal to and greater to, while it should be only greater than 50. Okay, so we got the issue, but this will not be the end of our root cause analysis, because we also need to understand that from where this requirement came to the developer. So it can be a mistake that by mistake a developer included this equal to sign over here in the code, or we need to understand if there was any other reason or not. Okay, so what we will do, we will go one more step behind, which is design. And during design, we saw that this was the requirement based on which the development, this was the design in which the requirement was captured in a way, when purchase is more than 49, 10% discount shall be applied. So based on this design, the developer did this in the code. He added this line in the code. Okay, so which means that now the issue was in the design, which led the developer to write this code, and in testing then we spotted out that defect. Okay, because in design it should be 50, not 49. So it was a series of events which took us backwards, which we had to go backward in order to identify the root cause of this issue, and we figured out that there was a mistake, an error which was made during design phase, which actually led to all these issues. So now I hope that you're able to understand that why root cause analysis is so important. We go behind. That person who wrote the wrong requirement will be trained, which means that after the training there are more chances that that person will know more about the system and how to capture the requirements, etc., which eventually will improve the process. So these are the reasons why we need to do root cause analysis. Okay, now moving on, we'll be covering testing principles. Okay, so there are some guiding principles that can help us to improve the quality of testing. So here are 7 principles that can be used as a guideline for all kinds of testing. And these are: testing shows the presence of defects. Number 2, exhaustive testing is impossible. Number 3, early testing. 4, defect clustering. 5, pesticide paradox. 6, testing is context dependent. And the last one, number 7, is absence of errors fallacy. Okay, so let's just go through all these principles in detail. So principle 1 says testing shows the presence of defects, not their absence. Testing can reveal defects, but testing cannot prove that the software is defect-free. Not finding defects does not prove that the software is correct. Okay, so when we carry out testing and we find a defect, then we know that there is a problem with the software. But just because we haven't found a defect doesn't mean that there is no defect in the software. So for example, let's say that there are 15 defects in a system, and during testing you found 10 defects. So it has reduced the number of defects, it has improved the quality, but still there are somewhere 5 defects present in the system which were remaining, and the testing couldn't identify it. So it doesn't mean that if you couldn't find those 5 remaining defects, then the defects are not there. The defects are still there. It's just that testing couldn't find those defects. So the principle 1 is testing shows the presence of defects, not their absence. Principle number 2, exhaustive testing is impossible. Exhaustive testing is testing using all possible combinations of inputs and preconditions. Okay, so let's take an example of a calculator. If you have to test a calculator, just imagine that how many combinations you have to use. So let's say that it's a 10-digit calculator. So you have to test all the operations with all the possible combinations of the numbers, etc. So that will be like unlimited number of test cases. So this is just an example. It can happen with many other software as well, where exhaustive testing is not possible, it's not feasible. So testing is therefore a subset of all possible tests determined by risk and prioritization. So because we know that exhaustive testing is not possible, it's not feasible, so what we do, we take a subset of all the tests which are important to execute, and how we determine those tests, that subset of the test is identified by their risk level and their prioritization level, that what is the priority of those tests and what's the risk level. So in the later sessions we will go into the priority level and risk levels more in detail. Principle number 3, early testing saves time and money. Okay, we should start testing as soon as possible. Whether it's dynamic testing or static testing, testers should be involved in the life cycle as early as possible. So to find defects early, testing activities should start as soon as possible in the SDLC, referred as shift left. Okay, so as we are talking about early testing, we are shifting to the left of the activities. So early testing is sometimes called shift left as well. It helps reduce or eliminate costly changes. Okay, if we refer to this diagram, we can see on the left hand side, on the y-axis, it's the cost of change, and on the x-axis we have different phases of an SDLC. So we can see that the cost of change increases when we find, let's say we find an issue in production, and if we are changing something at that time, that will be costly. So as we move ahead with our phases and we make any change, the cost of change is more as compared to the cost of change if we find something, let's say in the requirement phase itself, because we haven't gone through the entire phases yet of the life cycle. So it's easier for us to, it's easier and less expensive to fix something right in the beginning in the requirements phase, rather than once that software is in production. And this is the reason why testing should start early, as soon as possible. Principle number 4, defects cluster together. So a small number of modules contain most of the defects. Those defects can be responsible for most of the operation failures. Okay, so what is operation failure? It is when a product is in use and it fails to perform the function it is supposed to. So if we can identify the module which contains most of the defects during testing, then these will not creep into production. So defects cluster together means, like if you are testing a software and mostly it happens that let's say there are different modules and you are testing module number 2 and you found that there are lots of errors. Then what you do, you go into more detail into that module to see that, okay, if there are more errors or not. And sometimes it does happen that if there are 5 modules in that entire application, then there is one specific module where there are lots of errors, and that means that the defects are clustered together in that module. And it might be that maybe the requirement was quite tough, it was not it was complicated to implement, or maybe it was not clear, or it might be the case that the requirements not clear in that case as well. Maybe the person who captured requirement also didn't had much idea of like what is expected in that specific modules. So this is what is meant by clustering of defects. So that's why test planning should focus on the expected and actual modules containing the most defects, and that can then lead into a change into the requirements, because again the same activity of root cause analysis will be done, that what's the reason of defects clustering together in this specific module, and it might be the case of changing those requirements altogether. Principle number 5, beware of the pesticide paradox. Okay, it says that rerunning the same test over and over will eventually fail to find the new defects. Test cases should be regularly revised, including test data. In automated regression testing, the pesticide paradox has a beneficial outcome. Right, okay, so if we are testing a module and we have 10 test cases, so we ran those test cases, we found an issue, we fixed it, then again we ran the same test cases, we didn't find any issue. So it means that if we keep on running the same test cases again and again, we are not finding any new defects like this. So when by the term pesticide paradox, we mean over here is that the more you test software with the same test cases, the more immune it becomes to those tests, because we are not changing the tests. And it's similar to like as insects eventually build up resistance and the pesticides no longer works. So it's the same concept which applies to the test when we are running the same test again and again. So that's why if we want some different output, then the test cases needs to be regularly revised, and maybe new test data should be used. Only then there is a possibility that, okay, if there is any hidden bug which we are not able to find, then yes, maybe with some changes in the test data, or maybe the changes in the test cases may eventually lead to that defect, but otherwise there is no use of running the same test again and again. Okay, when we run automation testing, we are running the same scripts, but if we add new value of test cases, there is a chance to find more defects. Principle number 6, testing is context dependent. So testing different types of software and testing carried out in different circumstances may require different testing approaches. So it depends that what kind of testing you need to do in which circumstances. So for each, if there are different kind of applications, then maybe you will require to apply different testing approaches. For example, safety critical industrial control software is tested differently from an e-commerce mobile app, which is true. If there is a mobile app, which is an e-commerce mobile app, when we are testing that, then it will be different to the way you will test a safety critical industrial control, where if there is any issue, it can be life-threatening as well. So the approach you will take for testing these two different kind of applications, softwares, will be totally different. And then testing in an agile project is done differently than testing in a sequential life cycle project. So we take different approaches if we are testing a waterfall model, or if we are testing an agile project. So our testing approach would be different. So this is why the testing which is done is context dependent. It depends on the context, like the circumstances, the situation, which is comprised of different factors for that project. And the last principle is absence of errors is a fallacy. So some organizations expect that testers can run all possible tests and find all possible defects, which, like, this expectation is totally wrong, because we can't run all tests, and this is something which we already covered in principle 2, which was exhaustive testing is impossible. So in principle 1 and 2 respectively, we came to know that this is impossible, and further it's a fallacy. What does fallacy means? It's a mistaken belief that we can run all the tests. So it's an incorrect belief, and there can be defects or factors which can cause a product to fail. This is why we cannot claim that there is no defect in the software. So thoroughly testing all specified requirements and fixing all defects found could still produce a system that is difficult to use, that does not fulfill the user's needs and expectations. So let's say we have thoroughly tested something and we couldn't find any defect, but still it doesn't mean that it fulfills users' needs and expectations, because what if that software which was tested for defects, it was based on incorrect requirements. So the requirements were wrong, based on which it was developed correctly, but because the requirements were not correct, and at the end we came to know that though that system doesn't have any defect or many defects, but still it's no use to the customers because it's not meeting their requirements. So it proves that absence of errors is a fallacy. It's a mistaken belief. Right, so with that, we have come to end of our today's session. So let's just go ahead with some practice questions. So the first one is, which of the following statements best describes one of the 7 key principles of software testing? Let's just go through all the options. A, automated tests are better than manual tests for avoiding the exhaustive testing. No, automated tests, we can't say that automated tests are better than manual tests, and this will not avoid the exhaustive testing issue. B, exhaustive testing is with sufficient effort and tool support feasible for all software. That's incorrect as well, because what we studied is that exhaustive testing is impossible, it's not feasible. C, it is normally impossible to test all input-output combinations for a software system, which is correct. We can't test all the inputs and output combination. So C is a correct answer. But I would suggest that when you take the exam, even if you have found the right answer, please go through all the options. So let's just go through the option D as well. The purpose of testing is to demonstrate the absence of defects. No, this is incorrect as well. So we are sure that C is the right answer. Let's go ahead with the second one. So failure is, and we have options: A, incorrect program behavior due to a fault in the program, which seems to be the right one because we read this that an error leads to a defect, which can be a fault or a bug, and then in operation it can be a failure. So incorrect program behavior due to a fault in the program, it seems to be the right option, but let's go through the other options as well. Option B, bug found before product release. That's absolutely incorrect. C, bug found after product release. Okay, no, this is not a failure. D, bug found during design phase. So B, C, D are incorrect options. We'll go ahead with the option A, which is the correct definition for failure. Okay, with that, we have come to an end of our today's session. If you have any questions, please either just ask your question in the group or contact me, and as usual I will upload the session, and so that you can go through it later on as well, and I will also upload the questions as well in the group file section, so that you can go through the practice questions and try to attempt those. So I'll see you then in the next session, and till then, take care of yourself and bye.